So yesterday I received in my first batch of PCBs that I had ordered a couple of months ago. Well, to be exact, I believe it was the end of July, and I just received them in on September 15th, which was yesterday. These were manufactured by PCBWay. This video is in no way sponsored by them. I used them because I was able to find a $10 off coupon, and I could use their cheapest shipping to Singapore, which was the e-packet, which was only $7 plus a $1 fee. So the entire project of printing and delivering these PCBs only cost me $8. Each of these stack of 10 was only $5, so it was 5 and 5. One of the mistakes that I made, I should have done one batch in white and one batch in blue, red, black, and other color. And that's simply because the traces or the tracks on these are very hard to see in white. I can see them, but they're very difficult to see. And perhaps in your PCB this isn't a problem, but in my PCB I've created a generalized PCB where I'm using it for a number of different projects that have slightly different attributes. And I do need to cut the traces on some of these in order for it to work properly for that specific project. So for example, if I'm using the ATtiny to drive an LED, I need to put a resistor in. And in order for that resistor to work properly, I need to cut this trace here, which currently goes directly from the pin to this area here, which I've also set up as a transistor switch. So you could either use a transistor switch or you can use an LED in here. I'm wondering if you could actually stick a MOSFET directly in here. Yeah, you could, although it probably is not set up properly for the pin out of the MOSFET. But a transistor will fit in here well. But you can put an LED in here, but in order for the LED to have a proper resistor, you need to cut the trace in here. It's also set up so that you can have inputs coming in. So for example, I have a PIR module that I'm going to attach to this, which then feeds into the digital audio converter here, or I'm sorry, digital analog converter. So that goes direct into that, so there's going to be no resistor on that. Actually, I take that back. There would be a resistor on that because I just want to make sure that it's not sending too many milliamps to the pin. I believe that the PIR module has a resistor internal in it, but just in case, I'm going to put an additional resistor on that. So in that case, yeah, I'd also be cutting that resistor as well, or that pad over there, in order to put a resistor on this. So I do need to be able to cut these traces. So a different, different solder mask, a different color solder mask would be good for that. Also, as soon as I sent it away to PCBWay, I did notice that there were some mistakes thanks to the electronics community. I believe on Reddit, they suggested that I put a decoupling cap near the VCC of the ATtiny, which I didn't do. So in the next version, that's something I would do. I could probably get away with not having it on this because it's so low power. There's no other modules really being powered for the most part. It's not really going to cause a problem of brownouts on the ATtiny in this situation. But I could always just, put a small cap, a small ceramic cap on the VCC going into the ATtiny and find a ground to stick it to. Or even if I was going to do a surface mount, I could probably just do a surface mount, perhaps on the back side, and just scrape off a little bit of the solder mask in order to get a ground, because I did put a ground plane on the top and the bottom of it. And that was actually another mistake that I made, not to put the ground plane, but in the design of the PCB, if it was higher current, it would be a problem. It's a very low current, this entire project, or all my projects, so it's not going to be a problem as far as the nature of how current flows and how it has to flow back to the ground. It's not going to be a problem in this. If it has to go around a little bit more, if it's a little bit longer of a path, it's not going to cause interference or anything like that. So it's not a big problem. But for the sake of having a better design, yeah, I certainly learned a lot from producing this. One of the things that I thought was a good idea, and one of the features that I added to it, was the ability to program directly off of it. So the ATtiny, I put all the MISO and the resets and VCC ground directly over here, so that I could put a pin header on it, either on the top or the bottom, and do programming on it directly. so that I don't have to keep popping it off, put a dip in, pop it off, put it into a program, or put it back on. I could just program directly off of this. And I'm also using the TP4056 module on this so that I can use a LiPo battery or a lithium ion battery on it, which works very well. The TP4056 is a really good module for charging. It does overcharge, undercharge, all that sort of stuff, all the protections that you need. I also added some additional pads on it so that if I did want to, change it in some way, a feature that I'm not currently thinking of. So for example, right now I'm driving the LEDs directly off of the ATtiny. I added the ability to, drive it off or use transistor to switch it on or off. And this would also allow me here on these pads to add something like a MOSFET so I could drive even higher current LEDs or other devices without having to, create a new PCB to do that. So yeah, so overall, a really good outcome for this. This is a programmed one. So this is just Blinky running on an ATtiny 85. This would work, of course, on a smaller module or a less memory module, like a 13 even. But I just loaded up Blinky into it. I cut the pad, put the resistor on, and now I'm just running it off of the power of the Arduino itself. But for programming, you won't be able to get away with this because actually the reset is directly to the reset of the Arduino, whereas it really needs to go to the 10 pin over here. So you can't get away with programming it just by sticking it in, which is what I was originally hoping for. So you actually have to turn it over and stick in jumpers onto it and then jump it to the proper pins on the Uno or on the Arduino, whatever Arduino version you're running. So one of the things that I did before I had it printed, and I think it's generally a good idea, is to print out a version of the PCB before you have it manufactured, and this way you can just check to make sure that all your components are going to match. This is a really good idea. It's probably a good idea to have all your components before you actually order the PCBs so that you can lay it out on the board and make sure everything fits properly. Make sure you don't have any layout mistakes because sometimes the footprints for these are not going to match. I got very lucky. All my footprints seem to match. I checked the JST pins over here. They all fit. Or the Molex, whatever you want to call them, JST or Molex. I'm sorry, I'm not sure which you would call those. Those pins all fit properly. The resistors fit in well. The transistors fit in well. The LEDs fit well, even onto the transistor pad, which is exactly what I was hoping to do. So why don't I go ahead and load up my computer and I'll show you my PCB design and some of the mistakes that I think I've made and how I would improve it for the next version if I do print up a next version of the PCB. All right, so this is the final version that I sent off to PCBWay to manufacture. Let me switch off the copper plane here so that you can see the actual tracks a bit better. Okay, so I switched off the copper, and now you can see all the tracks in here. So what I was mentioning before about the copper planes, this is something that I didn't realize earlier was because I did a copper pour on the top and the bottom, I just kind of assumed that the grounds would be connected in an efficient way. Unfortunately, that's not really true. You do need to be mindful about the path that the ground is going to be taking back. So for example, if we take a look here at the ground over here, if we're talking about the top area, where the red traces are, for it to complete its path, it's actually got to kind of go around here, get stuck. Okay, so it's got to go through the back here, a little bit of an area over here. Maybe it can sneak through over here and go around, up, over, around, through this via, back to the backside, back through the top, or directly through the backside to the ground plane, or to the ground starting point. So not the most efficient path for a ground off the ATtiny to be taking. And if we take a look here, if we take again a look at the top level, it's going to go through here, It's probably going to wind around here, maybe go through here, and then back down. Not too bad. It has some other areas that it can probably go around here as well and over. And if you think about it in terms of the bottom copper pour, because these are through holes, so you have a bottom copper pour as well that'll connect to. That seems to be a bit better. So ground from here will just go straight down into here. Ground from here is going to go here. I cut the ground in half. This is what I was talking about earlier about cutting the ground in half. I cut the ground in half here with this track, which is bad. So it's probably going to hit the via up here and then go. It might also go around a little bit and hit the via over here and up, and in this via over here and up. So not the most efficient way, or not the best way to have a complete circuit of your current. And that's something that I learned after I had already sent it off, watching a lot more YouTube videos and learning about the way that current actually flows and thinking about the way that current flows in a circuit on a circuit board. So that's really important actually, is to think about the way that current flows on a circuit board and to try to make it the most efficient path. I also forgot to put a decoupling capacitor, as I mentioned earlier, which I would go over here. So let me show you what an improved design might look like. Okay, so this is the slightly improved version. And what I've done with this is I've replaced some of the tracks that were cutting across on the bottom layer, going vertical. I've replaced those with horizontal tracks only on the blue side or on the bottom side. And what this allows is for any current from the ground to go directly back. And I did this. It wasn't too hard to do. I just had to redesign some of the routes a little bit. I've also added a capacitor here. A decoupling cap right over here, which would be a surface mount, easy enough to do. Let me get rid of that here. So now we can see that the ground has a lot of area to flow. It can just flow directly back here. I can go around here and go back. The ground here is just a nice direct path directly back to it. Ground here as well, go directly back. Well, actually this one will go around here a little bit and then come back. But the ground from the sensor here is going to have a nice direct path. Ground over here as well is going to have a nice direct path. So a little bit better as far as understanding the current flow, which is really important when you're designing these sorts of things.